When two equal and opposite forces act parallel to the cross-sectional areas of a cylinder, the shape of the cylinder changes as there is relative displacement between the two cross-sectional areas of the cylinder. This is very similar to the situation where we might deform a pack of cards or a book. The restoring force per unit area developed due to the shearing of the body is called shear or shearing stress. The corresponding strain developed in the body is called shear or shearing strain. In equation form, the shear stress is written as shear stress equals tangential force upon area of surface. The MKS unit of shear stress is Newton per meter square. The CGS unit of shear stress is Dyn per centimeter square. The dimensions of shear stress are L raised to minus 1 into M raised to 1 into T raised to minus 2. The shear strain is defined as the ratio of lateral displacement of any layer to its distance from the fixed layer. In the equation form, it is written as shear strain equals lateral displacement of any layer upon its distance from the fixed layer. Shearing occurs in rotating shafts which are heavily loaded. Shearing also occurs in bone fractures due to bending. Another situation in which the shearing occurs is when the spiral spring is stretched. In this case, the metal wire is twisted but not stretched. Volume or volumetric stress and strain. As shown in the figure, a solid object is placed deep into the fluid. The high pressure is applied to the fluid, which in turn applies uniform pressure on all sides of the solid. The volume stress is defined as the force per unit area which changes the volume of the body. In the equation form, it is written as volume stress equal to applied force upon area, that is change in pressure. The MKS unit of volume stress is Newton per meter square. A CGS unit is Dyn per centimeter square. The dimensions of volume stress are L raised to minus 1 into M raised to 1 into T raised to minus 2. The volume strain is defined as the change in volume per unit original volume of the body. Volume strain is also defined as the ratio of change in volume to the original volume of the body. In the equation form, it can be written as volume strain equal to change in volume upon original volume, and that is equal to dV upon capital V. The volume strain has no unit. Elastic limit. Bodies show elastic behavior when the external force is applied within certain limit. The elastic limit is defined like this. The stress corresponding to the limiting value of the load, which when applied and subsequently released does not produce permanent deformation, is called as elastic limit. Beyond this limit, the proportionality of stress and strain is lost. In fact, lesser stress produces more strain. Related to the concept of elasticity is the Hooke's law. It provides an equation which relates stress and strain. The Hooke's law states that within elastic limit, stress is proportional to the strain, that is, stress proportional to strain. Therefore, we can write the equality equation by introducing a constant of proportionality. Thus, stress is equal to constant of proportionality capital K into strain. The constant of proportionality is called the modulus of elasticity. It is found to be characteristic of a given material. Hooke's law is an empirical law and is found to be valid for most of the material found in practice. However, there are some material in which a stress is not proportional to the strain and hence Hooke's law is not valid.